I want you to picture a scenario. It's maybe 4 in the afternoon on a Tuesday. You've got a task that really should be simple.
Right.
Let's say you're summarizing a meeting transcript or maybe writing a SQL query. So you fire up your favorite LLM, you type in a prompt, you hit enter, and the output is just, well, it's garbage.
Oh, yeah. Classic. The universal experience right there.
So you sigh, you go back to the prompt, and you add a sentence. You type, don't be so verbose. Hit enter. Now it's way too short, so you add another line. Think step by step. And now it's hallucinating entirely. You are trapped in this loop.
The endless guessing game.
Exactly. Just tweaking words and hoping for the best.
I actually call that vibes-based engineering. You're trying to vibe your way to a solution.
Vibes-based. Yeah, and honestly, it feels less like engineering and more like casting spells or something.
Pretty much.
You're throwing ingredients into the cauldron and just praying the potion doesn't explode in your face.
Yeah.
But today, we are doing a deep dive into a case study that claims to completely kill the vibes.
Which is a huge deal.
It is. We are talking about moving from, I hope this works, to, I have mathematical proof that this works.
It's a pretty significant shift in how we interact with these models, honestly. We're looking at a tool today called the Vertex AI Prompt Optimizer. And the source material we have is really fascinating.
Yeah, it's a technical case study.
Right, from Alexander Nohe and Elena Urbicianu Tenor from the Firebase and Google teams. And they didn't just write a theoretical paper. They actually used this tool in the real world to automate a task that was driving their team crazy.
And that is the mission for this deep dive today. We're going to tear apart this case study so we can understand how automated prompt optimization actually functions under the hood.
Getting away from the guesswork.
Exactly. We'll look at the ground truth data they used, the millions of tokens they had to burn to get there, and honestly, my favorite part, we are going to read the actual monster prompt that the AI wrote for itself.
Which, spoiler alert, is something no human being would ever write.
Yeah.
It's completely alien.
It's terrifyingly specific. But before we get to the monster prompt, let's set the stage a bit. What was the actual problem the Firebase team was trying to solve? Because on the surface, it sounds really mundane.
It does sound mundane, but anyone who works in content knows this exact pain. So Firebase, and if you aren't familiar, that's Google's app development platform, they produce a ton of video content.
Right.
Release notes, tutorials, technical deep dives.
Yeah.
And every single video they upload to YouTube needs a description.
The text box under the video that absolutely nobody wants to write.
Exactly, that text box. But the thing is, that box is actually really high-stakes real estate for them.
Because of search and SEO.
SEO, yes, but also usability. You need a good summary, you need chapters with exact timestamps, you need relevant links to specific documentation, hashtags. It has to be accurate, or the developer comment section will absolutely eat you alive.
And historically, a human had to do this.
Right. A human marketing manager or a developer advocate would have to sit down with the video script, watch the video, and manually type all this stuff out. It's tedious.
So tedious.
It's repetitive. It is just the perfect candidate for automation.
So their hypothesis was pretty simple, right? Can we feed the raw video script into an LLM and just have it spit out the perfect YouTube description?
Right. But here is where most people fail when they try this. Most of us would just open a chat window, drop the script in, and say, hey, write a YouTube description for this.
And the AI gives you something super generic.
Exactly. It wouldn't capture the specific Firebase tone or the formatting of their documentation links or the specific way they handle header markdown.
So then you'd spend more time fixing the AI's output than if you just wrote the thing yourself to begin with, which entirely defeats the purpose of automating it.
Spot on. So the Firebase team decided to stop guessing. They brought in the Vertex AI Prompt Optimizer. But, and this is the absolutely key insight here, you cannot use an optimizer if you don't have data.
Okay, this brings us to the concept of ground truth. I feel like this term gets thrown around a lot in machine learning circles, but let's nail down what it actually means in this specific practical context.
In this context, think of ground truth as the answer key. So the team went digging into their archives. They took old video script stuff they'd already published in the past and put them in one column of a spreadsheet. That's the input.
Okay.
Then, in the column right next to it, they pasted the actual human-written YouTube description that went with that specific video. That is the target.
So ground truth is literally just what the human actually wrote back when they did it manually?
Precisely. Is the gold standard. It's the team saying to the computer, look, I don't know how to write the instructions to tell you to do this, but this right here is what the perfect result looks like.
Okay, so they built a data set. Scripts on the left, perfect human descriptions on the right. How many of these did they need? Are we talking thousands of rows of examples? Because that sounds like a massive lift.
No. And that's actually the really cool part about prompt tuning versus full model fine-tuning or training. They used about 45 examples.
That's it, just 45.
That is it. You don't need big data for this. You just need good data, high-quality data. So they exported this as a CSV file, uploaded it to a Google Cloud storage bucket, and that essentially set the stage.
Because now, instead of asking the AI to be creative, they effectively handed it a standardized test.
Exactly.
Okay, I want to get into the mechanics of this optimizer now, because I think there is a huge misconception that optimization just means the AI tries a few different synonyms. Like, it changes write a description to compose a description and sees what happens. But looking at the source material from Alexander and Elena, this is a heavy brute force process.
So it's an evolutionary battle. So you start with a baseline prompt. The Firebase team used something very standard. It was basically, you are the senior social media manager for Firebase. Your goal is to write compelling descriptions, include chapters and hashtags.
Which is exactly what I would have written. It's totally logical.
Right. It's an instruction-based prompt. It tells the model what to do, but it doesn't really tell it how to do it.
So you feed this basic baseline prompt into the optimizer. What actually happens next?
The optimizer enters a loop. It takes your basic prompt, runs it against those input scripts from your CSV, and generates new descriptions. Then, and this is the magic part, it compares its own generated descriptions against the target descriptions, the ground truth you provided.
It grades its own homework.
In a way, yeah. It uses a separate evaluation model to score the output. It literally asks itself, did I get the tone right? Did I format the links correctly? Are the timestamps accurate? And if the overall score is low, another part of the system steps in and says, okay, why did we fail? What instructions were missing from the prompt?
So it diagnoses the gap between its own output and the human gold standard.
Exactly. And then it rewrites the prompt to try and close that gap. And it does this over and over and over again. The case study mentions they ran this specific optimization loop for about 4 hours.
4 hours just for a text prompt.
It is extremely computationally heavy. They were using Gemini 1.5 Flash, which is a very fast model, but they still consumed millions of tokens during this process.
Millions, just to write a paragraph of instructions.
Because think about the math behind it. If you have 45 examples and you iterate 50 times, and for every single iteration you have to generate a new prompt, run the entire batch of 45 scripts, evaluate all those results.
The volume just explodes.
Exactly. It's exploring the latent space of possible instructions to find the most optimal path.
You mentioned something interesting in the notes about optimization mode. They didn't just use standard instructions, they set it to instructions and demo. What does that actually mean?
This is a crucial distinction for anyone trying to build these pipelines. There are two main ways to prompt a model. You have zero shot and you have few shot.
Break that down for us.
Zero shot is like saying, write a poem. You give it 0 examples. Few shot is saying, here are 3 examples of poems I really like. Now write a new one in this exact style.
Okay, so examples usually work way better because they instantly show the style you want.
Almost always. So the instructions in demo mode means the optimizer isn't just rewriting the text instructions of the prompt. It is also actively selecting specific examples from your dataset, the absolute best ones, and embedding them dynamically inside the prompt as a reference.
Oh, wow. So it's dynamically curating a few-shot prompt for itself.
Exactly. It figures out which examples best demonstrate the really tricky edge cases, and it stuffs them into the context window. It's teaching by showing, not just by telling.
Okay, so after 4 hours of this evolutionary battle, burning through millions of tokens, the machine finally spits out the winner, the optimized prompt. I'm looking at the before and after comparison in the case study right now, and wow.
It's intense, right?
The original was maybe 50 words long. The optimized version is a massive wall of text. It looks like a legal contract mixed with Python script.
It is an absolute monster, but we really need to unpack why it's a monster. Because buried in that huge wall of text are some fascinating insights into how the AI actually thinks, or rather, what it mathematically needs to function correctly.
The part that absolutely blew my mind was the timestamps.
Yes, this is easily the highlight of the entire experiment for me.
So the original prompt just said include chapters, but the input script, the text of the video they feed it, doesn't have any time codes in it. It's literally just a transcript of words. So how on earth did the AI figure out where the chapters start and end in actual minutes and seconds?
Right, because a human would just guess based on the flow, or they'd open the video editor timeline and check. But the AI cannot see the video. It only has the text.